Very good afternoon, students. Hope all are doing good, staying safe and healthy at home. How all how you all did your revision test today, chemistry? So I all thorough with these chapters. So far, what all we have completed? First lesson, second lesson, and gaseous state. Are you all thorough with these three lessons now? Okay. In the last class, we started with this lesson hydrogen. We discussed about the preparation properties of hydrogen and the isotopes of hydrogen also we saw. And then we stopped with the hardness of water. How that is permanent hardness and what is meant by temporary hardness, all that we discussed. Today we are going to see about the next part of the water, that is heavy water. Heavy water is the oxide of heavy hydrogen. One part of heavy water is present in 5000 parts of ordinary water, which means that's what we saw in the preparation of D2O also. How to prepare this D2O we saw. This D2O can be prepared by the removal of the hydrogen, so that minimum quantities of D2O will be staying as it is as you remove the hydrogen. So likewise, D2O is an heavy water of hydrogen. This is heavy hydrogen. If you take 1 ml of water, it will contain 5000 parts of this ordinary water. Okay, that is if you take this 5000 parts of ordinary water, in 5000 liter if you take, you can see this 1 ml of heavy water you can see. So it is mainly obtained as a product of electrolysis of water, as D2O does not undergo electrolysis as easily as H2O. So how can you prepare this? By electrolysis only. D2O is colorless, odorless and tasteless liquid. However, there is a marked difference between physical properties of water and heavy water. Just now we saw in the last class, we saw in the table. And this hard water produces less foam with detergents, because this hard water will not do its cleansing property. Instead of doing the cleansing action, it will start to precipitate. So it is very less. And chemical properties of heavy water. When compounds containing hydrogen are treated with D2O, hydrogen undergoes an exchange of deuterium. So you can see the hydrogen will be replaced by the deuterium. So NaOH, that is sodium hydroxide, reacting with heavy water will give you sodium deuterate, that is NaOD. Same way HCl reacts with D2O to give DCl, and ammonium chloride reacts with D2O to give ND4, that is hydrogen is just replaced by this D. These exchange reactions are useful in determining the number of ionic hydrogens present in a given compound. That is, these exchange reactions are useful for determining the number of ionic hydrogens. When you ionize them, how do they get polarized? So இதில் எத்தனை வந்து polarize ஆகுது, எத்தனை ஆகாதுன்றதை நம்ம ஈஸியாக கண்டுபிடிக்க முடியும். ஏன்னா அயனைஸ் ஆகிறது ரீப்ளேஸ் பண்ண முடியாது. அயனைஸ் ஆயிடுச்சுன்னா அது பிரிஞ்சிடும், நம்மளால் ரீப்ளேஸ் பண்ண முடியாது. ஸோ அப்போ நம்ம ஈஸியாக ஐடென்டிஃபை பண்ணலாம். ஃபார் எக்ஸாம்பிள், when D2O is treated with hypophosphorus acid, only one atom is exchanged with deuterium. It indicates that it is monobasic. அப்போ ஒன்று தான் ரீப்ளேஸ் ஆகுது, அப்போ ஒன்று தான் வெளியில் வர முடியுது, மீதி எல்லாமே அயனைஸ் ஆகாது. ஸோ அப்போ நம்பர் ஆஃப் ionizing hydrogen நம்மளால் ஈஸியாக ஐடென்டிஃபை பண்ண முடியும். It is also used to prepare some deuterium compounds. Aluminium carbonate, and then this calcium carbide, aluminium carbide, magnesium nitride, calcium phosphate, all these reacting with D2O to give the corresponding product as ஹைட்ராக்சைட்ஸ்ன்னு சொல்கிறத விட டியூட்டிராக்சைட்ஸ் ஃபார்ம் பண்ணுது. அலுமினியம் டியூட்டிராக்சைட், கால்சியம் டியூட்டிராக்சைட், மெக்னீஷியம் டியூட்டிராக்சைட், கால்சியம் டியூட்டிராக்சைட்ஸ் ஆர் ஃபார்ம்டு. What are the uses? Heavy water is widely used as moderator in nuclear reactors, as it can lower the energies of fast neutrons. It is commonly used as tracer to study organic reaction mechanisms and mechanism of metabolic reactions. It is also used as a coolant in nuclear reactor, as it absorbs the heat generator. ஸோ வெரி காமனாக இங்கே நியூக்ளியர் ரியாக்டரில் யூஸ் பண்ணுறாங்க. பிகாஸ் நியூக்ளியர் ரியாக்டரில் நியூட்ரான்ஸ் வந்து எமிட் ஆகிட்டே இருக்கும். ஸோ அந்த ஃபாஸ்ட் ஸ்பீட் ஆஃப் தி நியூட்ரான்ஸை இது லோவர் பண்ணும். அண்ட் தென் Organic reaction mechanisms trace, that is இப்போ carbon, okay, hydrocarbons இப்போ if you see this acetic acid CH3COOH இருக்கு, அந்த CH3COO ரெண்டு ஆக்சிஜனில் ஒரு வந்து நார்மல் ஹைட்ரஜன், இன்னொன்று ஐசோடோபிக் ஆக்சிஜனாக, ஒன்று நார்மல் ஆக்சிஜன், அதை ஒன்று ஐசோடோபிக் ஆக்சிஜனாக இருக்கும் பொழுது அதை நம்ம வந்து you can label them and you can do the reaction. ஸோ அதுதான் நம்ம tracer, used as tracer to study organic reaction mechanism. இது நம்ம we will see if that is there in your higher secondary, that is 12th standard. It is also used as a coolant. Okay, so coolant-ஆவும் யூஸ் பண்ணுறாங்க நியூக்ளியர் reactor. Moving on to the next compound. So far we have seen about water and heavy water. Moving on to the next compound of hydrogen, which is hydrogen peroxide, whose formula is H2O2. Is most important peroxides. It can be prepared by treating metal peroxide with dilute acid. So barium oxide and sulfuric acid reacts to give barium sulfate and hydrogen peroxide, and sodium peroxide reacts with water to give sodium sulfate and hydrogen peroxide. So in industrial scale, how they are preparing is, it is now prepared exclusively by auto-oxidation of 2-alkyl anthraquinol. So you have to take this 2-ethyl anthraquinol. So second position later, and this is an 3 rings or anthracene. So that is from there it came anthra. And then quinone, center structure is quinone structure. So when you react this with hydrogen in the presence of catalyst, and then addition of oxygen will give you the 40% solution of hydrogen peroxide. Physical properties. Hydrogen peroxide is almost a colorless liquid, which is pale blue and sometimes very pale blue, and colorless also, less volatile and more viscous than water. A 30% solution of hydrogen peroxide is marked as 100 volume hydrogen peroxide, indicating at standard temperature and pressure, because 100 ml of oxygen is liberated by 1 ml of this solution on heating. Chemical properties. Hydrogen peroxide is slightly unstable, and the aqueous solution is spontaneously disproportionate to give oxygen and water. So spontaneously it will get oxidized and reduced to give oxygen and water. This reaction is very slow, but it is explosive and catalyzed with metal. If it is stored in glass container, it dissolves the alkali metals from the glass, which catalyzes the disproportionation reaction. That is for this reason H2O2 are stored in plastic bottle. So if it is stored in glass container, what it will do? It will dissolve the alkali metals from the glass. So always it is stored in plastic bottles only. So hydrogen peroxide decomposes to give water and oxygen. Hydrogen peroxide can act both as an oxidizing and reducing agent. Oxidation is usually performed in acidic medium, while the reduction reactions are performed in basic medium. In acidic medium, you can see that is addition of electrons, and then you are adding an acid there. So it is forming water. Same way in basic conditions also it is happening. For example, if you see potassium permanganate reacts with hydrogen peroxide to give manganese oxide, potassium hydroxide, and water and oxygen. Uses: the oxidizing ability of hydrogen peroxide and the harmless nature of its products, that is water and oxygen, lead to its many applications. It is used in water treatment to oxidize pollutants, as a mild antiseptic and a bleach in textile and paper and hair care industry. Hydrogen peroxide is used to restore the white color of the old paintings, which is lost due to the reaction of H2S in air with the white pigment, that is lead hydroxycarbonate, to form black colored lead sulfide. So அதை நம்ம ஸ்டாப் பண்ணுறதுக்காக ஹைட்ரஜன் பெராக்சைடு என்ன பண்ணணும்னா அந்த ஆக்சிடேஷன் நடக்கிறத ஸ்டாப் பண்ணும். ஏன்னா ஹைட்ரஜன் பெராக்சைடு ஆக்சிடைசஸ் black colored lead sulfide to white colored lead sulfide, thereby restoring the color. Moving on to the structure, both in gas phase and solid phase, the molecule adopts a skew conformation. So the skew conformation na enna abdingrada we will see in the second volume. Skew conformation due to the repulsive interaction of the hydroxy bonds and the lone pairs of electrons on each oxygen atom. Indeed, it is the smallest molecule known to be shown hindered rotation about a single bond. So இங்கே பார்த்தீங்கன்னா இது ஒரு புக்கு மாதிரியான ஸ்ட்ரக்சர், இந்த ஹைட்ரஜன் பெராக்சைடு ஸ்ட்ரக்சர். ஸோ அந்த புக் சென்டர் பாயிண்டில் 2 ஆக்சிஜன் இருக்குது. ஸோ அதுக்கு ஆப்போசிட் பொசிஷனில் யூ ஆர் ஹேவிங் தி hydrogen. H2O2 has a non-planar structure. The molecular dimensions in the gas phase and solid phase differ, are shown in the picture. So structurally, hydrogen peroxide is represented by the dihydroxyl formula, in which the 2 hydroxy groups do not lie on the same plane. So 2 hydroxy groupum ஒரே planeல இல்ல. One way explaining the shape of the hydrogen peroxide is that hydrogen atoms will lie on the pages of a partly opened book. So opened book la centered position la you can see the hydrogen atoms, and the oxygen atoms on the along the spine அப்படினா the sidewaysல இருக்கு. Now in the solid phase of the molecule, the dihedral angle reduces to 90.2 degree due to hydrogen bonding, and the OOH angle expands to 94 to 101. Is it clear? Next is hydrides.